For IIT JEE 2024, the chemistry syllabus has been given outlined as three parts: physical chemistry, inorganic chemistry, and organic chemistry. In physical chemistry, there are about 8 chapters. In inorganic chemistry, there are five chapters, and remaining organic chemistry.
Correct.
So, coming to physical chemistry part, the first unit contains the basic concepts in chemistry. Here, what is matter? How is it? What is the nature of this matter? How these matters are classified, and what are the properties of this matter that has been explained. And Dalton atomic theory. This is the basic foundation for atoms that exist as individual entities. Then the concept of atom, molecule, element, compound. So what is the difference among these all? That and all we will discuss. Then coming to the laws of chemical combination, when chemical reaction is happening, what are those laws? So conservation of mass. Mass cannot be created or destroyed. Definite proportions. The proportion among the reactants in the products. Multiple proportions. When one reactant reacting with another reactant in such certain proportion, 1 is to 2 or 1 is to 3, like that, multiple proportions will be existing. Then Gay-Lussac's law, gaseous volumes combine in simple ratios. Uh, Again, the Avogadro's law, equal volumes of gases containing equal particles.
What is
Then
Avogadro? What is Avogadro value?
Avogadro's law is different, Avogadro value is different.
Hmm.
Then atomic and molecular masses. So what is the mass of an atom? What is the mass of a molecule? We'll define that, how atomic and molecular mass are defined. Then the concept of mole, that is the counting of substances in terms of a conventional way in chemistry. Then molar mass, the mass of a substance per unit mole, 1 mole. Similarly, the percentage composition, if two or more components are present in a mixer, what is the percentage of one component? That is one thing. Then empirical and molecular formula. Molecular formula simply represents how many atoms are combined to form a molecule. This empirical formula gives a simplest proportion of those all components as primary units. Then chemical equation, balanced chemical equation is the equation which represents the balancing of both the elements present in left and right sides, the proportion of the moles of the reactants and products is called as stoichiometry. Stoichiometry represents the proportion of the reactants and products. A balanced chemical equation says that it is according to the conservation of mass. Then atomic structure. So before going for detailed topics, what is an electromagnetic radiation? Electromagnetic radiation is a wave. It's also it, uh, properties are like light. One electrical force, one magnetic force, result of that electromagnetic radiation. Light is an example of that. When light ejects, when metals are exposed to light, electrons will be coming out. That is called as photoelectric effect. Then hydrogen spectrum, it is it shows that electron will have energy levels, and when it moves from lower energy level to higher level energy level, it absorbs some energy. Or if it comes from a higher energy level to lower energy level, it releases energy. That is seen in hydrogen spectrum. That was Bohr's has proposed like that. These electrons will rotate around, revolve around the nucleus in orbits with quantized energy levels. That is proposed by the Bohr. The dual nature of the matter, particle exhibits wave nature as well as the dual nature. Then de Broglie relationship, the wavelength depends upon the momentum. Lambda is equal to h by mv. H is the Planck constant, mv is the momentum. Then Heisenberg uncertainty principle. When electron is revolving around the nucleus, it's impossible to simultaneously assess the momentum and the position. So there is a limitation. If you can measure the momentum exactly, you cannot simply measure, simultaneously you cannot measure the position with a certain uncertainty is there. So quantum mechanical model is the probabilistic model of electrons position. When electrons are revolving around the nucleus, there will be multiple electrons. Each electron will have its own quantum number. So these quantum numbers define the electron properties in an atom. So orbitals are there. Orbital is nothing but the path of the electron that is revolving around the nucleus. It defines electron properties in atoms. The shape of orbitals, electron density distribution in s, p, d, and f orbitals. So electron filling rules. So when another electron is coming into the another atom, into an atom, it follows above principle, Paulus exclusion principle, Hund's rule. So Hund's rule says that when electrons are being filled, first the electrons will fill half, and then they'll pair. That is Hund's rule. Paulus exclusion principle says that no two electrons will have same number of same set of quantum numbers. And Abbo principle says that uh, the arrangement of the electrons will be according to their energy levels. So first, the outermost electron will have lowest possible energy as highest possible energy. When it loses the energy, it comes to next levels. So electronic filling rules are these three are. So electronic configuration is the arrangement of the electrons in an atom that depends on the number of electrons present in the atom. So the stability of the orbitals will get only when they filled half, and then fully orbitals are filled orbitals are stable. Chemical bonding and molecular structure. Coastal-Lewis bonding. The concepts of ionic and covalent bonding is explained there. Ionic bonding is the formation of bond and energy of ionic compounds. Covalent bonding is a shared electrons and bond polarity. VSE pair theory. It defines the shapes of molecules based on the electron repulsion, valence shell electron pair repulsion theory. So valency bond theory, hybridization of the atomic orbitals. Normally, when it's a single atom, there will be an orbital. If two or more components are forming a bond, compound or a molecule, then the orbitals will be hybridized. Those hybridized orbitals are according to the valency bond theory. Then molecular orbital theory. Bonding or anti-bonding of orbitals in molecules is explained as per molecular orbital theory. The bond properties are mostly the bond order, the length, and energy. Then
What is meant by
metallic
bond?
bond.
What is meant by bond order and length? How do you define a bond
How many
order?
bonds are there? One bond, single bond, a double bond, or triple bond like that?
Ionic band, covalent band, like that.
No, 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 not like that. Order is different.
Ah,
How many orders? How many bands? Single bond is there, double bond is there between any two atoms. Triple bond is that like that. So bond order, bond length, and bond energy. When this bond is formed, how much energy is utilized or released? So metallic bond is one. The electron C model in metals.
correct.
Hydrogen bonding is the bonding of hydrogen with strong intermolecular attraction forces and electronegative forces. Then coming to the chemical thermodynamics, the fundamentals of the thermodynamics deals with the system that we are observing, the surroundings which are around the system, and various properties like enthalpy, internal energy, entropy, free energy, and these are all state functions. So state function means at a given state, the state of matter is defined in terms of the variables temperature, pressure, and its composition. So this state is a function of temperature, pressure, and its composition. When this state is changed with different temperatures and pressures and compositions, that is called as state of that system. So the first law deals with the conservation of energy in the systems, and conservation of the energy means energy cannot be destroyed or created, but it may change from one form to the other. Similarly, the heat capacity, the heat required to raise the temperature by 1 degree temperature. Enthalpy changes, energy involved in reactions and phase changes. The second law deals with and entropy and spontaneity of the process. The Gibbs free energy deals with the spontaneity and equilibrium. When a reaction is going on continuously, if the free energy is negative, then it is possible for the spontaneity. Otherwise, it's not possible. Spontaneity means on its own without any external effects. Then the solutions. Solution is a homogeneous mixture of two or more components, and the concentrations of so mostly the more available component is called as solvent, less available component is called as solute. So how much amount of solute there is in a given amount of solvent, that is called as the concentration. These concentrations are measured in different ways, like molarity, moles per liter, molality, moles per kg of the solvent, mole fraction, moles of component divided by total number of moles, etc. These methods are these are the methods for expressing the concentration, including the molarity, mole fraction, and all. These are by percentage, by volume, by mass. Like that, we can tell. That is concentration terms. Raoult's law says that the vapor pressure in an ideal and non-ideal solutions, the vapor pressure relationship in ideal and non-ideal solutions, including the vapor pressure composition plats. So how this vapor pressure is related with the composition of that component in the mixer or solution. So when solute is dissolved in a solvent, there are some problem and some properties changing. The effects depend on the solute concentration. The properties depend on the solute concentration, such as relative lowering of the vapor pressure, freezing point depression, boiling point elevation, and osmotic pressure. These are the colligative properties. The colligative properties mean are nothing but the properties that are changed for a solvent when a solute is dissolved. Then molar mass determination. Using colligative properties, calculation of molar mass using colligative properties of dilute solutions is possible. Similarly, there is a factor called Van 't Hoff factor. It accounts for ion dissociation solutions. It adjusts for an ion dissociation or association in solutions impacting colligative properties.
Yes.
Then
This is according
chemical
to
equilibrium.
2025 syllabus I prepared. Okay. It's the latest
Yes.
syllabus. Unit 6, equilibrium.
In equilibrium, this is a chemical equilibrium. It's a dynamic steady state equilibrium, you can say. That is a constant state in irreversible reaction. Reversible reaction. The concept of equilibrium in reversible physical process, including the solid liquid, liquid gas, gas liquid, and solid gas equilibrium, along with Henry's law. So a dynamic equilibrium means between solid and liquid there will be distribution.
Yes.
Some components in solid, some components in liquid will be there. They will be distributed according to the equilibrium conditions. There won't be any change in the composition of the each phase. And similar to that, chemical equilibrium. It's a balanced chemical reaction. There are, according to the law of chemical equilibrium constant, Kp based on the pressure, Kc based on the concentration, and their significance, what is that, and the influence of the Gibbs free energy on this equilibrium. These are the topics that are dealt. Then similar to, especially for the chemical equilibrium, Le Chatelier principle is one of the important
Concept.
concept. So
Concept.
when the reaction is going on, the reaction shifts due to external changes. The effects of the concentration or pressure or temperature and catalyst on the shift to equilibrium. Initially, there will be already existing equilibrium. When these parameters are changed, there will be a shift from left to right or right to left. That depends on the parameters. So ionic equilibrium is the dissociation of acids, bases, salts, ionization of weak and strong electrolytes, the concepts of acids and bases, Arrhenius theory, Bronsted-Lowry theory, Lewis theory, and acid-base equilibria with ionization constants. These are some of the topics that we come across in ionic equilibrium. Then pH. pH is a measurement of the concentration of the hydrogen ion. pH is equal to negative logarithm of H plus concentration. And a buffer solution is a solution which causes no change for the pH, even for small changes. So this is acid-base balance resistance to pH change. The pH scale is between 1 to 14. 7 represents neutral, 1 represents less than 7 represents acidity, more than 7 represents alkalinity. So the solubility product of a sparingly soluble salts, the calculation of and its significance of solubility product for sparingly soluble salts. This is one topic that we deal in solutions. So redox reactions and electrochemistry. Redact oxidation and reduction. These are two concepts. So oxidation reduction to simultaneously will happen, and there will be a balancing between that. So fundamentals of oxidation and reduction reactions. What is an oxidation number, and what are the rules for oxygen balancing and redox equations? These are some of the topics that we discuss in redox reactions. Then electrolytic and metallic conduction, conductance in materials. So normally in metals like wires, electric wires, they are all metals only. So metals, the electricity passes through by means of electrons. And whereas in the electrolytic condition, that is a solution kept in between two electrodes. So passage of the ions will cause for the movement of the electrons. So the conductance in materials, including electrolytic solutions, molar conductivities, and applications of Colrad's law will cause for the electrochemistry. Electrochemical cells are there. The chemical energy in this what happens is the chemical energy is converted into electrical energy. The structure and function of electrolytic and galvanic cells, the types of electrodes, and what is electrode potential, and what are the cell reactions. These topics will come across in this chapter. Then electromotive force and Nernst equation. Calculating the cell potential, calculation of cell potential using Nernst equation and its relation to Gibbs free energy. Then electrochemical applications. Where do we actually apply for this? In batteries, fuel cells, dry cells, practical uses in batteries, and lead accumulators. So these are some applications. Then the chemical kinetics. So when the reaction is happening, the concentration of one component, either it is reactant or product, will be continuously changing with respect to time. So reaction rate is measured as the speed of the chemical reaction. So it is defined as the speed of a chemical reaction and factors affecting it, such as the concentration, temperature, pressure, and catalyst. So reaction rate is defined as the rate of change of concentration of a component with respect to time. Then order and molecular of a reaction, rate loss, and reaction mechanisms, order and molecularity. So when the reaction is written in terms of a mathematical equation, the power raised to the concentration term is called as order. Maybe it is zero order, maybe first order, it may be half order sometimes, or even it may be second order, or it may be a fraction also. So when the reactions are happening, that that depends upon the rate depends upon the temperature and concentration. So the temperature dependence of the reaction represented by Arrhenius equation in terms of the activation energy and the absolute temperature to understand the effect of the temperature on the reactions. Then collision theory, which says that the reaction probability based on particle collisions The explanation of these reaction rates based on the probability of particle collisions, particularly for bimolecular gaseous reactions. Here we stop, sir. Hello.
సార్ చెప్పండి. నెక్స్ట్ కొలిజన్ థియరీ. ఆఫ్టర్ దట్ ఇన్ఆర్గానిక్ కెమిస్ట్రీ యూ కెన్ స్టార్ట్.
So inorganic chemistry mainly depend upon the classification of the elements and how the properties are being uh, repeated. So
Yes.
periodic law.
Yeah, please explain everything.
This represents the organization by atomic number, and modern periodic law, the structure of periodic table, and classification into in terms of uh, blacks, SPDF blacks, their elements, the trends of the periodic trends, patterns in size, energy, and reactivity,
Yes, correct.
and
Yes.
electron gain enthalpy, valence oxidation states, and chemical reactivity. Then S and P black elements. So from for P black from the group 13 to 18, the electronic configuration, properties, reactions, and trends across periods and within groups. Then first element anomalies, unique behavior of the first element in each group due to small size and high electronegatividity. So these are
Correct.
all some of the topics we come across in this P black elements. Similarly,
Correct.
D and F black elements. D black elements are called as transition elements.
Correct.
The general introduction for this electronic configuration, occurrence and characteristics, the trends in physical properties, ionization enthalpy, oxidation states, atomic radius, color, catalytic behavior, magnetic properties, complex formations, interstitial compounds, alloy formation, the preparation of the properties and uses of some compound potassium dichromate and potassium permanganate. Then actinides and lanthanides. Lanthanides, the electronic configuration, the oxidation states, and lanthanide contraction. The size along the period will decrease. Then actinides, electronic configurations and oxidation states with unique properties of inner, inner transition elements. Then coming to the coordination compounds, compounds that are made with coordinates, different coordination numbers. So Werner's theory and Legend's, the structure, bonding concepts, coordination number, denticity and chelation, and coordination compounds. The nomenclature here the IUPAC naming rules for mononuclear coordination compounds, the isomerism, structural and stereoisomerism in coordinate chemistry, bonding theories, valency bond theory, basics of crystal field theory, explaining color and magnetic properties. So their applications and qualitative analysis, material extraction, biological systems, etc. discussed in this topic. And coming to the organic chemistry, there are about 8 chapters. Chapter that purification and characterization of the organic compounds. How to purify these components? What are various techniques? These include crystallization, sublimation, distillation, differential extraction, chromatography, and each process, each separation techniques will have its own principle and their applications. Then qualitative analysis of the components. So to detect the elements, any element, whether it is present or not, to detect that is qualitative test, mainly in syllabus, like nitrogen, sulfur, phosphorus, and halogens, fluorine, bromine, nitrogen. These organic compounds can detect whether they are qualitatively present or not. Next, quantitatively, that means estimation of the carbon, hydrogen, nitrogen, halogen, sulfur, and phosphorus, along with calculation of chemical and molecular formulas. You can find out quantitatively. So, some principles in organic chemistry, how this carbon hybridization, tetravalency, carbon shares 4 electrons. So, the simple molecules and hybridization involving the S and P orbitals. Then organic functional groups, different functional groups are there. They are classified into based on their functional groups containing halogens, oxygen, nitrogen, sulfur. The concept of homologous series. That isomerism is the structural and stereoisomerism, geometrical and optical. That means same molecular weight, and there will be change in its structure. Arrangement will be different. So this nomenclature is very important. IUPAC naming conventions for organic compounds, International Union of Pure and Applied Chemistry. That it has formulated some guidelines how to name a particular compound. According to the IUPAC, naming conventions are being done in modern chemistry. The covalent bond fission, homolytic and hydrolytic fission, formation and stability of free radicals, carbocations and carboanions, the concepts of electrophiles and nucleophiles. So that most of the organic chemistry molecules will react and exhibit specified behavior. So this effects are explained in this theory. So electronic effects in covalent bonding, that is inductive effect, electromeric effect, resistance, and the hyperconjugation. So to study the mechanism of the chemical reactions, these all concepts are important. The reaction mechanism, what type of the reaction it is, what type of the organic reaction it is, including the substitution, whether it is getting added or eliminated or rearrangement, what type of the reaction it is. So that gives the reaction mechanism. Then unit 5 gives the introduction
Hydrocarbons.
about alkanes, called hydrocarbons, that is carbon and hydrogen. Alkanes, alkenes, and alkynes. Alkanes are the saturated compounds, have a different structure and conformation. And alkenes are geometrical, exhibit geometrical isomerism. They are electrophilic addition will be taking place, and ozonolysis can be done, and polymerization will be done. Similarly, alkynes, triple bond compounds, acidic character, addition reactions like hydrogen, halogens, water, hydrogen halides, and polymerization reactions take place. And aromatic carbon, hydrocarbons, these are structural compounds, ring compounds, especially the structure, aromaticity, and electrophilic substitution reactions like halogenation, nitration, Redox reaction, alkylation, acylation, etc. And substituent effects, direct to influence of functional groups in monosubstituted benzene, like that. So organic compounds containing halogens, haloalkanes, and haloarenes. Alkanes means
What
saturated
is meant by
hydrocarbons.
halogens?
Halogen means fluorine, halogenic group. Fluorine, chlorine, bromine, iodine, astatine. These are
That
the
type.
halogens.
Why it is called
Halorene.
halogens?
10th class students, why we are saying instead of this college, that is a classification. Common name. 10th class students is a common name
Okay.
that include everything. Like that, here
No,
also
no,
is
there is a specific meaning of halogens. What is the meaning of halogens and how the
that meaning I
classification?
don't know. It's a common name that I no I cannot remember right now.
Okay.
Then the substitution reactions mechanism of carbon and halogen bond. So environmental impact, uses and environmental impacts of chloroform, iodoform, freons, DDT, etc. Then organic compounds containing oxygens. So alcohols, phenols, and ethers. Alcohols are OH group. They may be primary, secondary, or tertiary alcohols, and the dehydration mechanism
Correct.
take place. Phenols are acidic in nature.
Uh,
Electrophilic substitutions like halogenation, nitration, sulfonation, and Riemann-Tiemann reaction. Ethers, structure and properties. These are some topics that are there in a first chapter. Then aldehydes and ketones. Aldehydes, carbonyl group C double bond O. That is
C double
ketone.
bond అంటే
They
కార్బన్
have to be,
డయాక్సైడ్ C double bond O అంటే
huh?
C
No, no, no.
double what is that carbonyl group
Carbon
అంటే
is making two bonds with oxygen, two electrons shared by electron.
that's what
Oxygen.
example give example.
Ketones. Carbonyl group is nothing but ketone.
Okay, ketone means if you are not going motion properly, if you are not releasing your motion 2 3 days, it will become as a ketone, you know.
That is reactions, biochemical reaction, that and all
Yes.
another part. Then reactivity and reactions that includes Grignard reaction, oxidation, reduction, alpha hydrogen acidity, aldol condensation, Cannizzaro reaction, and haloform reaction. So these are all some of the reactions that happen because of the aldehydes and ketones. Distinguished tests, chemical tests are differentiate aldehydes and ketones. So carboxylic acids, acidity and typical reactions such as esterification and decarboxylation. An organic compound containing nitrogen, amines. How amines are classified? What is the nomenclature? How is the nomenclature? Its structure, basicity, and identification of primary, secondary, and tertiary amines. What are various tests available? Diazonium salts, preparation, properties, and significance in synthetic organic chemistry. Then coming to Unit 19, biomolecules. Biomolecules are nothing but molecules that present in living cells. Maybe it is plant cell or animal cell or any microbial cell. So in all these, there will be carbohydrates. What are structures of carbohydrates and what are how many types are there? And proteins, that is amino acids and protein structure. Vitamins and nucleic acid. So that is the roles of DNA, RNA, and vitamins. And carbohydrates, how they are classified, like monosaccharides, disaccharides, oligosaccharides, and polysaccharides, aldoses and ketoses, the types of these functional groups. Example, glucose as an aldose and fructose and ketose. Like that, there is a distinction between aldose and ketose. Monosaccharides, the structure and importance of glucose and fructose. Oligosaccharides, composition and structure of sucrose, lactose, and maltose. These are all
What as I say, sucrose we know, and sucrose chemical formula we know. Can you explain the formula for lactose and maltose? Sucrose I know. What about lactose and maltose? Do you know the chemical
similar to
formula?
that. I can't remember right now.
Ah, that is
So next point is
okay.
next proteins.
What is meant
Mainly
by
they include
protein?
amino acids.
How do you define protein?
Protein is proteins are amino acid groups. Amine group, carboxylic acid group. Both will be there. The structure of alpha amino acids will as building block of proteins and peptide bond, that is bond formation and chain structure of proteins. The protein structure, primary structure, secondary structure, ternary structure, and quaternary levels. Different conditions under different conditions they will have different shapes. So primary structure, secondary structure, like that. Denaturation, the loss of the structure and function due to external factors. So enzymes are also some sort of the proteins only. They are biological catalyst. Their role in metabolic process is very important. They
Suppose
activate.
metabolic process means suppose I am taking whatever the food left in the night. I kept in the water and I mixed with the curd and onion, chili and salt. Morning I am taking that as a my breakfast so that my metabolic process will change in my life. My digestion system,
Metabolic
yeah, metabolic.
maybe generally the for digestion purpose there should be an alpha amylase
Uh,
which cuts starch materials into breaks into smaller particles. So if alpha amylase enzyme is produced, automatically it happens. Then vitamins, they are classified as water soluble vitamins and fat soluble vitamins. Vitamin B complex and C, the water soluble, and fat soluble, vitamin A, D, E, and K. The function of these vitamins is their roles in vision, metabolism, immune health, and other bodily functions. And nucleic acid, their composition is structure of DNA and RNA, including the nucleotide composition. The biological functions of DNA for genetic information, storage, and RNA for protein synthesis. Hormones, general induction. What is that? Chemical messengers regulating the physiological process in the body. Body structures all defined by hormones. Next, coming to the practical chemistry, qualitative test whether an element is present or not, to identify that, like nitrogen, sulfur, and halogens, organic compounds, how to identify, how to detect an element. That is called qualitative test. This is in syllabus. And functional group test, identifying the test for the hydroxyl group, or alcoholic or phenolic group, or carbonyl group, or aldehyde or ketone group, carboxyl group, amino acid groups in organic compounds. Then compound preparation. Some reagents can be prepared in lab. Inorganic compound prepared synthesis of more salt and potassium alum, and organic preparation acetanilide, paranitроacetanilide, aniline, and iodoform. These are included in the syllabus. Titrometric analysis exercise, acid-base titrating using indicators, redox titrations with oxalic acid versus potassium permanganate, and more salt versus potassium permanganate. Then the qualitative salt analysis, identifying the cations like lead, copper, aluminum, iron, zinc, nickel, calcium, barium, magnesium, ammonium, and anions like
No,
carbonyl,
it is not
sulfide,
NH4. NH4 is
sulfate.
ammonium, NH3 is ammonium.
NH3 is ammonium and
Ah,
H4 is ion.
you need to say that one. You are saying ammonium. Okay.
Cations like,
Ah, and
then
anions. Okay. Continue.
anions like carbonyl group, sulfate group, nitrite group,
Ah,
chloride group, bromine, iodide, bromide, iodide, like
that
that.
is halogens. Okay. Ah, thermo.
Thermochemistry deals with the enthalpy of the solution, measurement of the enthalpy change for copper sulfate. The copper sulfate is dissolved in water. What is the temperature range change? From that, we can calculate enthalpy of neutralization, determine the enthalpy for reactions between strong acid and strong bases. Colloid preparation, formation of lyophilic and lyophobic sols, solutions. The reaction kinetics, study of the reaction rate between iodide ion, and hydrogen peroxide at room temperature. Like that, some of the topics are included in
So
the
that is
syllabus.
practical. That is practical. So 20 chapters. Remaining these IIT JEE 2024 chemistry syllabus you have already covered in the PPT. I am going to stop recording. You have explained 30